The one more thing, um, whatever I completed last 5 to 6 class, I think, not third module, the second module last after this, that is elective cryptography is not there in your new syllabus. Just I told you, right? The previous, no, yeah. I came to know recently that the recent like afterwards they changed the syllabus. In that they removed some of the syllabus, so that is why. So elliptic cryptography, starting from elliptic cryptography is not there till the end. Only till other applications after Diffie-Hellman, I think, right? Elgamal things are there. After that, yeah, here other here. Hmm. That things are not there. Huh? Yeah, other applications here till here. The third mod is here. So in the public key infrastructure, we are discussing in the third module now. In the public key infrastructure, there are 4 types of public key infrastructure architecture, out of which one which we discussed last class, PKI with the single CA, right? Whereas a single certification authority will vouchers the certificates to the multiple people. So that is called a single. It is normally like this. For example, certification authority 1 is going to issue the certificate to user 1, user 2, like that, the n number of users, like this. There are multiple things. But the problem is, as we discussed last class, there is a single point of failure in this. The reason is it is not scalable. It is not scalable one. So this is called as single CA. That is A. That is first one. B. The hierarchical model or PKI. It looks like this. CA1 initially issuing a certificate to CA2, CA3, CA4, like this initially, and then CA2 issues a certificate to CA5 as well as user U1. Okay, user number U1. Then CA3 will issue the certificate to CA6 and user 4. CA6 and user 4, user number 4. CA4 will issue the certificate to user 8, 9 and like that. U8, U9, U10, U11 and CA, this is 5. Okay. U2, U3, U4. Sorry. U4 is already there. U2 and U3. Sorry. U2, U2 and U3. And CA6 will issue the certificate to U5, U6 and U7. Yeah, in our tree based or hierarchical based, PKI issues like this. The certificates will be issued in this way. The basic things here is one CA, he can issue the certificate to other CAs as well as other users. The meaning is like this, right? CA1 can issue the certificate to other CAs, and in turn CA2 can issue the certificate to other CAs as well as other users. For example, U1 vouched by CA2. The path will be like this. For example, U1 will get the certificate in CA1, CA2 like this. This is the path to get this. Similarly, a U5 will get a certificate in such a way that CA1 will watches CA3, CA3 watches CA6, CA6 watches the public key of user 5 like this. So here what is in this case, how to verify this? The verification is very simple in such a way that, for example, U1 is the user. He wanted to verify user 5, user 5's public key or certificate. What he will do is, initially he will contact CA2. CA2 in turn contacts CA1 because his parent one is CA1 only. Similarly, the U5 initially issued by the CA1, then CA3, then CA6, and then U5. So the U5 has to give the information to the U1 in such a way that all his predecessors, who are all, for example, U5 actually got the certificate from CA6, Certification Authority 6. But CA6 got the certificate from CA3 and CA3 got a certificate from CA1. In this way, here, suppose the U5 has to provide this particular link CA1, CA6, sorry, CA3, CA6. Then this person will verify in this direction. Similarly, the U1 has to give the information to the U5 in a similar way, or U11, for example. U11 will be like that. CA1 watches CA4 and CA4 watches the public key of U11 or user number 11 in this way. That means finally all the user will get the one or the other person or other particular certification authority. So these authorities will issue not only to the users, they also issue the certificate to other CA also. In this case, only users. You see, CA1 will use. So the scalability issue is solved here, right? The scalability, it is not scalable. Thus not scalable, but it is scalable. Scalable in such a way that we can multiple things, that means multiple CAs will arise and those CAs will issue the certificate to other people. Like that, they will do the, or finally they will watch us all the users public key. This is the tree based hierarchical public key infrastructure. Next one is mesh based PKI. Mesh based PKI. In the mesh based PKI, the certification authority will issue the certificate in mutual. For example, in this way. CA1 will issue certificate to CA2. CA2 will issue the certificate to CA1, and similarly CA3, the bidirectional thing, and he will issue the certificate to user 1, and CA3 will issue the certificate to CA2 as well as CA4. Each other in this way. This is also possible. And then again CA5 and CA6 in again tree based. Because it is a combination of tree based as well as, for example, U2, U3, U4, U5, like this. These are other things. Okay. Now let us will see in the mesh based PKI, what are all the additional things compared to the previous two. In the hierarchical based CA, one CA can issue the or vouchers the certificate to other CA only one, and reverse is not true in that case. But here mutual trust of CAs, that is mutual trust of CAs. Mutual trust of CAs means each CAs, they will issue the certificate each other. There is a mutual understanding between the two different. And here multiple trust paths between the two users. Multiple trust paths between the users. Multiple trust paths means, for example, U1 or for example CA3. CA3 will get the certificate from CA1. Similarly from CA2. Similarly from CA4. And the belongings or CA3 will issue the certificate to CA5 and CA6 again. And CA5 will in turn this way. For example, user number 3. The user number 3 will get the certificate in multiple paths in such a way that, for example, U3 certificate or public key is vouched by CA1, CA3, CA5. That is a one path. Another path is CA1, CA2, CA3 and CA5. One more path. One more path is CA1, CA2, CA4, right, CA3 and CA5. Another path. I think still one more you have, right? What is that? One is this path. Another one is this one, right? Correct, no? One more is this. Any other path? 1, 2, 3. Again, no. 1, 2, 3. Direct. These are all the these are called the multiple paths to get the certificate for U3, user number 3. Any other path is belongs here? No. Similarly, U5 will get the certificate in the similar way, but only U1 will get the directly from the CA1. Only U1, and rest all others will have the multiple. This is called as a mesh-based PKI. Mesh-based PKI. The last one, bridge based PKI. Bridge based PKI. Main need of this bridge based PKI is for the purpose of secure communication between the organizations. Okay, need to secure the communication between organizations. Let us say organization A and organization B. In organization A, they have the tree based hierarchical or tree based PKI structure. Similarly, organization B also they have the again the tree based structure or PKI. Now there is a bridge between these two organizations to communicate among these people. So that is called as bridge based. How? That is through a representative CA from each organization. It will work in this way. Let us say this is called as a bridge. That is bridge based PKI. In the organization A, for example, or organization A may be a representative called as CA. Similarly, here representative called as CB, certification authority CB. And PKI of organization will be like this, whatever it may be. So this is the PKI. Similarly, the PKI of B. Organization B will look like this. Now the thing is, CA is one organization's architecture is different than the others. This PKI may be something like mesh based or a single CA based or tree based, anyone. Similarly, this organization's PKI may be of a tree based or single CA based or else the third one, that is mesh based, anyone. And these two are representatives actually. This is called as representative CA of the both the organizations. Representative CA. And through this representative CAs, you can out the certificate by using the bridge based PKI. How? For example, user who belongs to the organization B, for example, U7, he may be belongs to CB. And similarly, user of U9, user number 9, he may belongs to the organization A. So he may get the certificate through the CB also, right? By using the bridge based, right? He may be watched by U9, and U9 certificate is watched by the CB, certification authority B, organization B. Similarly, U7 certificates will be watched by the CA via this method. So this is the bridge based. This is called as, and basically it's addressing the each organization. And within the organization, they have their own structure, whether it's a tree based, mesh based, whatever it may be. But along with that, they can verify each other. For example, U9, he wants to send a message to U7. What he will get the public key of U7. The public key of 7 is watched by the CB. So he will get the through this bridge basis. That is, verification happens through here, and then he sends a message to the by using that public key, and he will get the message. Again, he will verify U9 in the same manner. Again, he will verify the certification authority A, that is organization A, and in turn he will send the messages. This is about the public key architectures. So there are 4 different types of architectures. One is unique one, single CA based, and tree based, mesh based, and bridge based. Next, certification or certificate revocation. Certificate revocation. Various scenarios you have to consider first. Scenarios. Scenarios of certification revocation or certificate revocation. First one, the employee of an organization, he quit the organization. One, employee quits the organization. Then you need to revoke his certificate in such a way that, for example, when he gives a resignation, his certificate is under the suspension, because he is not supposed to use that. Otherwise, there are some misuse of the certificate. So, head of the organization will suspend his certificate, because once he quits the organization, he belongs to the some other organization, or he may belongs to his own personal organization, and he is not related to any organization. Then there are some chances of misuse of that particular certificate, and the customer is unknowingly send the messages to this certificate by verify. After verification of certificate, the customer will send the messages to him only, and it will be handled by him only, and finally it's a mess of various problems. So to avoid that one, we have to use the certificate revocation method. This is the one such scenarios why the certificate revocation is required. Why it is required? Because certificate validity is already there for another 1 year or another 6 months, another 5 months, like that. For example, the certificate was validity was happened on January 1st, and it expires on December 31st, right? But in between, so in the month of April, the employee quits the organization. Then his certificate should be in a suspension, and then it should be revoked once the new person will come and join that particular place. So that is a procedure. There is one such scenario. Second one, compromisation of private key. Private key. What happens when the compromisation of a private key of a certification authority? This is another scenario. Let us say the architectural representation CA1, and he will watch CA3, suppose, and in turn the CA3 will watch 2 more people, CA6, and a user, any user, user number 1 or user number 10 or something. Now the scenario is here. Private key of the CA3 is compromised. Okay, private key of the CA3. Now the scenario is, just check it. Actually, the public key of CA3 was vouched by CA1, right? Issued by CA1. Public key as well as private key pair normally is vouched by the CA1. But he lost his private key and it got compromised. Means someone took that key, private key. Then there is the type of attack which happens to the other users, one who belongs to this particular community, because he is actually a certification authority for two different users. Again, that user may issue the several other certificates, sorry, several other people. He may certify, for example, he may give the another by using the tree basis, another CS, right, C3 set of CS, and they may in turn give the several certificate, other certification authority. They will issue the certificate to several. Then finally what happens? Because of the compromisation of this particular person's private key, rest are all other private keys also in a danger situation. So because of him, because he, so that is why you need a scenario called, sorry, you need a method like certification revocation. Again, revocation request has to send to the admin, and admin has to, or the particular, for example, CA3 certification authority CA1 suppose, and CA1 has to revoke the certificate, like that. So what are all the attacks or possible attacks which could happen in the compromisation of CA3's private key? It will be like this. Anonymous attacker who wish to or attack the all other people in such a way that he initially gets the private key of him by some other method. Private key is somehow compromised, whatever the method it may be. Okay. Then what he will do is, he will be having the private key of CA3, so that that person will request CA3 for a new set of private and public keys. For example, X is private key, okay, Y is public key. Again, he will create the new two pair of, that is one pair of public key, sorry, that is by using the public key cryptography, he will create new private key as well as new public key, and he will send a request to the CA1 by using this private key, existing private key. Okay, because somehow he took the private key from the CA3. On behalf of CA3, he will send a request message to CA1, and he is requesting for the new set of keys. That's it. That means during that time, the old private key is not exist. The new set of private and public key will exist. Upon receiving the new set of private and public key, he will issue the certificate to all these people, whatever he belongs to under the CA3. He will issue, this new person or attacker will issue a new set of keys by using this revocation method. Again, he will send all you have to update your certificates, because he is the person who having the certification authority, person who is the right to change the certificate or verification of certificate or something like that. So then he will send the messages to all other people, and this is a type of attack which happens in the case of the compromisation. So by using certification revocation is possible. But what are the different types of solutions which can happen here? for the certification. The solution number 1 will be like this. You have to make use of a protocol called online certification status protocol. Online certificate status protocol, OCSP. By using this protocol, you can come out of this particular problem, or you can overcome that problem in such a way that whenever your compromised, private key is compromised, you have to give the complaint to the online. In the online, you will get the status. Your private key is compromised, for example. And that is why you applied for the new set of keys or certificates. From the CA1, suppose CA3 certificate is a CA1, he will requesting for CA1. So that is through online only you will getting. And you are not supposed to use any other methods other than this online method. Because online protocol, the status protocol will give the clear picture time to time. That is one solution. The solution number 2, distribute the revoked certificates. Distribute the revoked certificates by using certification CRL, certificate revocation list, certificate revocation list, CRL. Certification revocation, who are all applied for the revocation. So here will clearly you will get the picture. Otherwise, suppose a third party is applied for the revocation on behalf of you. During that time, you will get the clear picture of it. You will get the status that your certification is under revocation. So revocation, actually you people are not at all applied for the revocation, but it is under revocation. So then immediately you can give the complaint against that and you can find out. Otherwise what happens? You are still using your old certificate and that person will using the new certificate along by issued by the certification authority, and he will acting on behalf of you for the other people. So this will continue, but it is very difficult to find out that. So the thing is, only thing is, the certification authorities, they have to publish or distribute the revoked certificates time to time. Third problem is, or solution is TTP, that is trusted third party. You have to use trusted third party method. Solution number 3, TTP. The use of trusted third party. So there will be a third party who is going to make sure that, or who is going to give the validation or verification for your certificate, and he will be the whole and soul responsible for the entire thing, because he is going to manage all your public as well as the private key set, or as well as the certificate. Whoever is handling it, maybe trusted third party will be there. Okay, how it happens? You will see the one scenario, trusted third party methods. So certificate is valid on one or certificate was opened on this way, like this. So certificate valid from this date. Okay. It's a timeline. I am explaining the timeline for that. And verifications which happens T11 and signer's key is compromised somewhere here. Signer's key compromised on April 1st, suppose. Okay, on April 1st. And T2 and T3 are the other two verifications which happen. Again, certification revocation received. And it is in August 1, suppose. This is 31st, 12/18. Valid to date. Now this is a different cases. Case 1. Case studies 1. And the type of signature generation time as well as verification time. Signature verification time. And does verifier accept the sign? Does verifier accept the sign? That is the one thing. Yes or no, you have to give that. And one more thing is, should verifier accept the sign? Accept the sign. Case study 1. At a time T1, let us say at a time T1, and signature verification time is T3, suppose. Okay, this is the one case study. Signature generation time is T1, whatever the time it may be, but you will get the date, clear picture here. That is before the key compromisation. When the key is compromised on April 1st. When you actually applied for certification revocation, August 1st. Okay. Now the thing is T1 and T3. T1 is generation time. That means you actually signed on the particular digital document. And T3 is the verification time. During that time, does verifier accept the sign? Yes. Why? Because the verifier is not sure about whether it is compromised or not. When it got to know that only when the certification revocation, right? Then should verifier accept? Yes. Because it is yes, then it is accepted. Case 2. T1, generation time is T1, same. And there is a one more time here, that is T4. Does verifier accept the sign? No, because generated on this time, for example, it may be February, and verification which happens on after the August. That means once the revocation list is distributed after voting. So it is actually no. So verifier will not accept. Should verifier accept the sign? Sign. Because verifier will accept the sign. Sign is accepted. Why? Sign is proper, but only time is not proper. This means this particular certificate, it is under the revocation list. It is a valid one. That is why he will accept. And the certification revocation list. That is why here there are two things. Does the verifier accept the sign? Because this is just a verification process. The verification process which will give the output that it is not or no. But verifier will accept the sign. That is the case. And case 3, I will tell you the case. Signature generation time is T2. Suppose here. And signature verification time is 3. What happens in this case? Yes or no? Does verifier accept the sign? Yes. Yes. Because signer's key is compromised here, right, at April 1st, but still he signed the document. The thing is, he is not aware of that compromisation of the certificate key. The user, that is one who signed the particular digital document, he is not aware that actually his key is compromised. When it happens? August 1st. August 1st, he make a complaint to his authority that my this one is, I have to put it under the revocation list because my thing. And in the meantime, that T3, this person is also not aware of that, signer, even verifier also not aware of that. So that is why it will accept. Now, fourth case, T2 and T4. He signed without knowing without aware of that. Okay, fine. That is not his problem. He is not aware of that. The signer signs that. But verification happens on after the revocation list is distributed to all. That means the verifier is not supposed to. That is no. And once that is done, then it is also should verification. That finally, the last column is actually a dummy, because it depending on the identity of the person, they will accept and reject. That is. But totally, it depends on this. Totally, your certificate validity will depend on this, yes or no. The verification, first time verification. Correct. These are all the cases. You understood the cases? Like there is time, because it's a time based, because as per the timeline,